Okay, so this is how you do problem 29. So remember that in a square root, we want to rationalize it by completing it. That is making a number that is a perfect square. Here, with a cube root, we want to make a perfect cube. So when we look at 36, we think, oh, that's 6 squared. If only that were 6 cubed. So the thing we multiply is that cubed root of 6. That is, what term do we need to create a perfect cube? Once we have that, we multiply it top and bottom. On the top, I just multiplied 6 by 60 to get 360. I don't know if that reduces, but that's not really the point of this one. And then it equals the cube root of 216, or 6 times 6 times 6, on the bottom. And we know that the cube root of anything cubed is itself, so that should be a 6, which gives us cube root of 360 over 6. Okay, for problem 41, we have the cube root of 375a to the 5th. So if you do some prime factorization, you'll find that 375 is 5 times 5 times 5 times 3. And those 3 5s are exactly what we're looking for. Again, just like in square roots, we looked for pairs of numbers, things that were perfect squares. So here we're looking for perfect cubes, that is, triplets of numbers. So the 375 has 3 5s, a 5 to the 3rd. That's going to turn into a regular number. It has a leftover 3, which stays inside the radical. It has a cubed root of a to the 5th. So how many a's can we bring out in groups of 3? We can bring out one group, so that's a to the 3rd. That becomes an a outside. And then there are 2 a's that are left behind, so they stay as a squared inside the cube root. So the idea behind the last one, I'm not going to do it, and you're not going to see something quite this challenging on the test. But you would do the same thing you just did. You would rationalize like you did over here. So the terms you would need to complete the bottom. So to turn a 4 into a perfect cube, well, a perfect cube for 2's is 8. So if I multiplied the bottom by 2, I would get a perfect cube. And if I wanted to get a perfect cube on b, I would use b squared, because b squared times b to the 4th is b to the 6th. b to the 6th would work, because it's a cube. It's divisible by 3. But again, don't stress over this last problem. Number 45, was it? Yeah, you won't see something quite like that on the test. Something more along the lines of these two. Okay?